In this video, I'm going to show you how to make a vision cone for your non-playing character. Sometimes you want more than just one single ray going out to see if you could see another player or another non-playing character. This is a vision cone that I put beams on so that you could see what's happening. If we run through here, let's go ahead and get our output window. There we go. We run through the beams. We are getting messages saying, hey, he saw us, right? Obviously, you wouldn't need this in the game unless you wanted to have like some sort of laser detection system. Right here, I just slowed the loops down so you can see what's happening. We're going to start in the center and work our way out. We can make more and more of these beams too, but beams are kind of expensive. So I spread them out a little bit. Let's go ahead and clear our output window. This is the finished product. There's no beams. You don't need to see them, but he can see us, right? And we can see that there's print statements spewing as we're running through the beams. I'm hiding now. He can't see me. If I can get up here, I should have made that a little shorter. There we go. Now he can see me, right? We got the print statements coming out. Let's go get down here. Clear. See that? He can see us. That's pretty cool. Let's go ahead and get started with our vision cone for non-playing characters. I have an empty base plate right here. There's nothing in my world. And the first thing I'm going to do is add an avatar, right? I need a rig or an NPC, something like that. I'm just going to do this rig builder. Click that, the avatar tab. You could do R15 or R6, doesn't matter. And then I like the mesh avatar 2016. You could use any of them, right? This will work for any of them. It'll even work for a part. So if you want to put this on like a video camera or something, you could do that. All right, so we got our rig. And I don't want to get moderated, and these default colors are not sufficient. So I'm going to delete them because I don't feel like picking colors. I'm going to add, hit the plus again on the rig. I'm going to do the default colors. If you add them, you get the green shirt and the blue pants. That's sufficient to not get in trouble. All right, now what do we need to do? I'm going to do a beam coming out of his head so we can see the ray cast while we're working on our code. It's good for troubleshooting, right? You don't have to do this if you think you got it down, right? But I'm going to do it for the video. So on the head, in the rig, on the head, hit the plus, attachment, right? And this is going to be the base attachment for the beam, ATT0. That's what I'm going to call it. I'm going to duplicate it, Control D. There we go. This is going to be the part that goes out into the world. It's going to follow the ray, right? So we'll do a ATT1. And now on the head, hit the plus, hit a B for beam. And this beam is going to be attached to attachment 0 and attachment 1. So on the beam, let's go down to where it says attachment 0. Click to the right, go to ATT0. Right? And now let's go to attachment 1. Click to the right, attachment 1. Now we can't see the beam. Why? Because attachment 0 is not out yet. Right? So that's what the beam looks like in its default settings. Oh, I'm sorry. I hit attachment 1, right? That's the one I pulled out. But it'll work with either one. But I think I'm going to move the attachment 1 out. It makes more sense. All right, let's change our beam settings a little bit. Let's click the beam, and then we'll go to the width. I'll make that maybe 0.1, and then this one, 0.1. Should we change the color? Whoops, I got hit enter. Change the color. Let's see what we got here. Yeah, make it like a red or something. Cool. And then maybe you could change the transparency a little bit. I think I'll do that. Transparency is 0.5. That's not bad. I'll leave it like that. Light emission, make it shine a little bit. There we go. And then face camera. What is that one? What is it called? Face camera right here. There. That way, wherever you're at, you can kind of see it as the regular beam, right? You don't have to worry about looking at it on the edge. Now, don't worry about how far out this is going to do. We're going to do that with code. So let's go back to our ATT0, get the world position, Control C, and then go back to ATT1, Control V on the world position. We're just going to suck it right back into his head. So you didn't even really have to pull that out except for modifying the beam so that you could see it better. Now let's click on our rig, right? Hit the plus, add a script, SCR if you don't see it, script, a regular script, a server script. And I'm just going to call this one C. Let's go to the top. We'll get rid of the print statement, and I'm going to get a variable for my character. I'll call it char, and that's going to be script.parent. I'm going to need a variable for the humanoid because I want to turn the C stuff off when he's dead. So we'll say hum, because I have trouble spelling humanoid, char, colon, wait for child, humanoid. I got some IntelliSense there, so I didn't have to spell it. Let's get the head, because we have our beam on there, right? So we'll say char, wait for child, head. Now I'm going to need a filter table for my raycast. So I'm going to say local filter table. And this is going to be all the stuff that we're going to ignore. All right, and now what are we going to do? We need the parameters for our raycast. So I'm going to call that params. And we'll just make that equal to a raycast params object. So we'll say new, a new raycast params object. We'll get our table. We'll do the table, I should say, we'll do the table insert on the filter table. There it is. And we're going to put our character in there. We don't want our character interfering with our raycast, right? Like the head in particular, but even his hands and feet and stuff like that. We want to be able to go right through it. That's why we're putting the whole character into our table, our filter table. Let's get the params now, right? So this is all raycasting stuff. So you'll need it. We'll say filter, how about filter descendants instances filter table. So any instance that is in here is going to go into the filter table, and we're going to be able to see right through it. How are we going to see right through it? Well, we have to get our params, and then we're going to say filter type, and then we'll do enum raycast filter type exclude, right? So exclude that. Don't let the ray, just have the ray go right through it. Don't let the ray detect it. And then I also want to get a variable for my vision distance. I'll just call that vision dist. We'll say 80 studs. How's that? You can make it as big as you want, right? Now, here's the tricky part. We got to make our cone, right? So I'm going to use some fancy terminology here. I'm going to use all caps for my constants. So I'm not going to change this while the script is operating. That's what a constant is, right? It's not a variable, it's a constant. It stays the same. I'm going to say half angle degree. This is going to be my angle of my cone. Half of it out from the center to the edge, I'm going to make it 30 degrees. Now, people can see further than 30 degrees, right? They can see almost 90 degrees, but we're going to make the cone a little more specific for us. Just remember, the bigger the cone, the more rays you're going to have, and the more computationally expensive it's going to be. Now, what else do I need? How about the ring step degree, right? And our cone is going to have little rings in it that go outward, and this is going to be the distance between the rings of our cone, right? We'll say 5 degrees. And what else? Oh, how about azimuth step degree? Now this is going to be the distance between the rays within a ring, right? So you're going to have the little ring. How far away do you want each little ray? So the smaller the number, the more rays you're going to have around in the ring. Remember, this could be computationally expensive, so you're not going to get, you don't want to go too crazy on it. All right, now I want to do a couple functions, right? Let's just set up the functions first. Let's say local function. We're going to have a vision cast function, right? We're going to have our origin. We're going to cast out our ray in this. And then we're going to have the direction with length. How far out you want that ray to go and where do you want it to go? And then we're also going to pass in the parameters for our ray cast, the ones we set up top there. What else are we going to need? I'm going to make a function for looking. I'm going to call it look. So we'll say local function looking. That's better. Looking is better. All right. I like it better. And let's not fill that out yet. We'll get back to it. And then we're going to do our while loop. So here, if you're worried about too many resources being spent on looking at stuff, you might want to have the while somebody of interest is around by using the tag system. I am just going to make this guy look as long as he's alive, right? So I'm going to say hum.health. While hum.health is greater than 0, do. We're going to put a little weight in there. How about task.weight? Maybe 0.3 seconds. You know what? We should make a variable for this. If you put the number right in there, they call that a literal, and then pure computer science people, the purists, don't like that. It's good coding to make a variable for it. Let's call this loop pause. Loop pause, right? We don't want it to run too fast. It uses a lot of resources. Let's just do 0.3, and then we'll get our little loop pause. And then instead of having the 0.3 here, boom, right? Now we can use it for other stuff. Like you might want to speed up this loop when enemies are around, right? And then right here, we're going to do our looking, right? So we'll just loop through looking currently every 0.3 seconds. Now looking is going to call the vision cast. That's our array cast. So I'm going to do vision cast prior to the looking function. Let's do local result will be workspace : raycast. And we are going to have our origin, which we don't have yet, but we will, right? We pass that in, and then we're going to get our direction with length, and we're going to pass in our params. So you could see that I basically just pass these down to the raycast. Now let's place our beam so we can see where the beam's going. We are going to comment this out though for normal vision. But like if you had like a laser or something, you wanted to see it. Here's our beam. If result, right? We hit something. If we hit something, then let's make the ATT1, the attachment 1 that's on the head, it's part of the beam. We are going to set the world position equal to the result dot position. Else, do we have ATT1? We do not. Let's get a variable for ATT1. Go up to the top. It is on the head, right? ATT1 equals head, wait for child, ATT1. Cool. Go back down here and continue. So else ATT1 world position, what will that equal? Let's just go origin plus the direction with length. So it's just going to shoot out into space. It didn't hit anything, but we still want to see our beam. Now what do? Let's check to see if the beam hits something. You know what I'm going to do right here? I'll say if not result, right? And I didn't put it in here because I might want to comment that out if I don't want to see the beam. So I'm going to do a separate if statement here. If not result, then let's just return, right? The beam didn't hit anything. Move along, right? But if it did hit something, we're going to get down here. We're going to say, how about local hit equals result dot instance. Now, what did we hit? We only care about characters, right? So let's do this. Let's say local, well, character is also a model, right? Let's check to see if it's a model first. If the hit, we'll do find first ancestor of class model. And if it's not a model, so if not model, we just hit like a random part. Let's just go ahead and return, right? And if the model has a humanoid, then we know there's a character involved, right? So we'll say local, let's call this ehum because our character has a humanoid. This is going to be for enemy hum, or probably hum of interest, but ehum will work. So we'll say model. We could do a find first child. You could also do like find first child of class, but this will be sufficient. Let's check to see, did I got my humanoid spelled wrong? I do. I have trouble with that word. Humanoid. It didn't give me any IntelliSense for it, too. Humanoid. Awesome. If not ehum, then return. There's no humanoid. Not a character. We don't care. Just return. All right. If we get all the way down here, well, that model was a character because there was a humanoid. So then I'm going to return the model. That should do it. Now we should probably test this before we start building out our cone. So let's go down to looking, and I'm going to need this for the cone too. Let's do a local base. We're going to get the base part, and that's going to be the head, not the base part, the base C-frame, the head C-frame, and then we're going to get our origin for the ray. So origin is going to be the base dot position. And then what else? Let's get the distance. I'll just make a variable for that, which I spelt wrong. There we go, dist. That's going to be our vision distance. I probably could have just used that directly. How about we do, let's get a variable for any ECHAR we find. Let's just cast out our vision cast. We're going to have our origin and we have our base, right? Let's do the base dot, we have our C-frame look vector. So that's the the direction, and then we need to add the distance, and we also have to have our parameters. So we'll do a check if ECHAR, then print ECHAR equals ECHAR.name. So make sure you do this if, because we're going to actually call the name. Let's see if we get it. Let's do a play. View, output, nothing's happening. We do see the beam. We're going to break the beam, right? We got to be there every 0.3 seconds. It's going to be called. You can probably see that. So it's firing away. Nice. All right, let's turn this off. Let's get back to our code. We know that much is working. If it's not working, go ahead and troubleshoot, see what you missed before we get too much going in our looking function. Now in our looking function, we are going to need 2 for loops to create the rings of the cone and then the steps within the ring, right? The azimuth steps. So we're going to do 2 loops. I'm going to start here. I'm going to do my for polar degree. This is going to be making the rings of the cone. And I'm going to start with the ring step degree. So I'm not starting with 0. I'm starting with the first value for my ring step degree. We're going to go out to our half angle, which is out from the center. The cone, the total cone angle is 30 degrees right now. And then we will do steps of ring step degree, which makes sense, right? And for our ring size, it's going to be approximately the sine of the polar degree, right? So if you haven't had trig in a while, you're just gonna have to trust me. Let's say local ring scale. We'll call it ring scale. We'll say math sine, and then we need radians. So we're gonna do a math rad to change the degrees to radians. We have polar degree here. Problem is, in the center, these values might get small, and we're going to need to do a divide by ring scale. So I need to clamp my ring scale so it doesn't get too small. So ring scale equals math. Let's return the max value of either 0.25. I just picked that because that's a reasonable value, or the ring scale itself, right? And this is where you're going to see why. So inside the ring, or every time we make a ring, we're going to have a different azimuth step, right? Because we're going to have more or less rays within the ring depending on its size. So I'm going to say local, how about azimuth step equals math dot max. Once again, I'm going to clamp it. I'm going to make a minimum of 2 degrees for my azimuth step. And then you'll see why here. When I do math floor to try and get the step size, I am going to use the azimuth step degree divided by the ring scale, right? So I'm doing some scaling of the rings, but we don't want this one to get too close to 0. That's why we have this. And then we don't want this to be too small, so we're giving it a minimum value of 2 by returning the maximum of whether it's 2, like if this gets too small, then we'll return a 2. Right? Hopefully that makes sense. If not, you just copy along. It's going to work if you get everything the way I have it. All right, so we got that, the azimuth step. Now we're going to do another loop. We're going to say for azimuth degree, this is going to be the loop counter. I'll just start with 0. We'll go 0 to 360. And then we're going to have our steps of azimuth step, right? Azimuth step do. We could probably, like we did here, we started on the degree. We could do that, or we could just like subtract 1 off, right? Because 0 and 360 is going to provide the same number. There we go. Just reduce it by 1 so we don't have to do it twice for the same value. Now I'm going to need to, how about get our ray C frame? We're going to have to calculate that out. So say ray CF will equal our base times C frame angles, right? And I'm going to do the X and the Z separately for our angles. So we'll do 0, 0, and then math.rad for the azimuth degree or asim degree. I think I can move this down a line. Yeah. And then we're going to multiply, how about C-frame angles? Let's do the X now, right? So the X was the polar degree. That was the outer loop. So we'll say math rad polar degree. I probably could have saved some time, but just make it a variable for that. Oh, well, this will work. And then 0 and 0. All right, so that's going to calculate where we're shooting off at, depending on where we are on our ring and on our step size. So we need to get that direction. We're going to get the ray C frames look vector for that direction. Now I'm going to get this, do a control X to cut it. I'm going to paste it in here. This is going to be the DIR, right? This value right there that we just created, right? Distance parameters. I think we are done. Let's test it, right? Just get rid of a couple white space lines there. Hit the play button. Oh, you know what? We got to put a weight in there because it's too fast inside the loop. Let's do this. C. And then how about put a weight right here? Let's do a task.weight, and now we could see our little beam move around. Let's do that. There we go. And then it'll be a 0.3 second pause at the end of the loop. That's a pretty big loop. We're going out pretty far. The reason the shotgun I do a square sweep is because I don't want to go as high. I don't want to make the cone perfect. So if you want that one, you should get that. I'll put the link in the description of the shotgun. Let's go ahead and test it out though. Here we go. Here we should be detecting us. It's going to be a slower detection process because we got that delay in there. We're not going to hit it every time. Let's go ahead and fix that. Let's make it production worthy. Let's go back to C. We'll get rid of this. And in order to speed things up quite a bit, we're going to get rid of we're not going to see the beam. I'm going to highlight all of this. Do a control / to do a group comment, and then let's play it. Come here. And now it'll be faster. Every 0.3 seconds we're going to get a hit. Cool. Now the thing is, in real life, people can see almost 90 degrees. Let's go ahead and see how we can change that, right? So we go to the C, right? Go up to the top. Oh, look at that. Half angle, 30 degrees, 90. And then you may want to play with these numbers. Just remember, we're going to have a lot more rays. It's going to get more expensive. That's why I liked the rectangle cone, right? But watch this. All we have to do is move up a little bit, and he can see us, right? He can see us at 90 degrees. All right, that's pretty cool. But he can't see from behind. See, the number stopped. All righty, I will see you in the next video.